Hi, in this demo, we're going to show how to set up HCP boundaries so that your remote users can securely access infrastructure resources even when your organization's network restricts all inbound access. This is a boundary feature called multi-hop sessions, or sometimes referred to as multi-hop workers. So from a previous demo video, which I'll provide in the description details, we showed how to set up boundary using a proxy called a self-managed worker. The purpose of this worker is to act as the entry point into your organization's network, which is more secure than having public IP addresses for each and every one of your resources. Of course, this means that the self-managed worker would need to have a public IP address. But what if your organization restricts all inbound connections and only allows outbound traffic to the internet? Or what if your organization has a really complex network topology where connections to your targets require access through multiple enclaves of internal private networks? In either case, multi-hop sessions can help. Let's look at the first example where an organization restricts inbound access from the public internet. In this case, we can set up multi-hop sessions with the use of an HCP managed worker, which is automatically created when you deploy an HCP boundary cluster. All you have to do is configure your self-managed worker to initiate an outbound call to create the persistent connection, and set tags so that your boundary clients can route through the workers in order to reach your targets. Alright, so let's jump right into the demo and show you how to set this up. I've already deployed a brand new HCP boundary cluster. So we're going to navigate to my AWS environment, and you'll notice that I have two brand new EC2 instances that I've already deployed. One is in Ubuntu EC2, the other is going to be another Ubuntu EC2 that'll serve as my worker. So now let's go back to my boundary cluster. If I click on workers, you'll notice that I have two HCP managed workers that have already been deployed for me. And let's add a new self-managed worker by clicking on New. And if you've seen my previous video on self-managed workers, this will be familiar to you with a few slight differences. So the first difference is this worker public address. Since we don't want to allow any inbound access, we don't need to have a public address for this worker. So we'll leave this as blank. The next field is the config file path. This basically is the path to the config file on your Ubuntu worker instance. So I'm just going to use the default provided, home Ubuntu boundary. And then next we're going to provide a tag. This can be anything you want, but I'm going to call it tag multi-hop. Then make sure you click add. And then it says to go to your worker and enter these commands. So I'm going to copy this command here, and I'm going to go to my worker. And on my worker, first of all, you'll notice is that I am allowing inbound access so that I can configure this worker. So it does allow SSH access right now, but I'll remove it later. So let's go ahead and SSH into it. And once we're on, what we'll do is we'll paste those commands that we copied earlier. And that will create a directory, and we'll go into this boundary directory, and you'll see a boundary config file as well. And what we'll do is go back to our boundary UI, and then we'll copy these config contents that was generated for us, and we'll paste it into our config file. And in a normal production use case, that would be it. But since this is a demo, I do want to add one setting, which is to disable memory lock, which is something I'm doing for demo purposes. But in production, you'd want to enable to allow Boundary to lock the memory on this instance. All right, so I'm going to save and quit. And by the way, if you want more details about setting up multi-hop sessions, all the information is provided in our documentation, and the link will be provided. But basically, you go to our documentation, look for multi-hop sessions, and there's a whole section here that talks about setting it up, which is basically what we just did. All right, so now let's go back to our Boundary UI. We'll scroll down here, and it basically says to copy the set of commands, which is going to install boundary and start boundary on the worker. So let's go ahead and do that. All right, so now boundary has started. So let's scroll back up to the beginning and grab this token that was generated. We'll copy that. We'll go back to our boundary cluster and we'll scroll down and we are going to add that token here and then register this worker. All right, so if we go down, click on done, you'll see that this is that new worker we just added. We click on it, it'll say that is last seen a couple seconds ago. So this confirms that it's able to communicate with this new self-managed worker. All right, the next thing we want to do is create a new target and configure it so that the connections from an end user's machine will route through the HCP managed worker to the self-managed worker and then to the target. So let's go ahead and go to our AWS org, go to the project, and then we will go to targets and we will create a new target. And now let's give it a name, demo target. And I will select SSH. We'll use the target address of our EC2 instance. We'll use the private IP address. And then we'll select port 22. And then lastly, we'll give it an alias. And this will be a name that the end user would enter when they want to SSH in. So it could be something as simple as just the name of the EC2 instance, which is Ubuntu target. To confirm that, let's see. Yep, that's just Ubuntu target. And we'll click add and save. So now we have our target. Now we want to ensure that traffic to our target goes through the correct workers. So let's do that in the workers tab. So what we'll do is select egress workers and edit the worker filter. So this is where we can tell Boundary to route traffic to this target by using only workers that match the correct tags. But if you don't happen to know what your tags are, you can go and look for that. So you can go to the workers and click on the worker in question, click on tags, and then you'll see the actual key value pair for this worker. So this is the tag that you'll want to put back onto your target. So let's go back to orgs, click on my AWS org, go to the project, click on targets, go back to my target earlier, then go to the workers and go back to editing the egress worker. Then this is where you'll enter that tag. But if you don't know what the format is, we have a filter generator to help you out. So we'll have tag selected, and then we'll enter the key value pair here, which was tag and multi-hop. And if you notice on the bottom, it generated the Boolean expression for you. So all we have to do is copy that and paste it back up here. And that's it. We click save. And so now it's successfully saved. So what this means now is in order to reach this target, Boundary will only route traffic through self-managed workers that have this tag. And as you can see now, this diagram pretty much reflects what we want to do. We want to connect from the client to the HCP worker, and then it'll go to the correct egress worker based on the tag we just told it to look for. And then from there, it'll connect to our final target host. And so now the final thing we want to do is inject credentials on behalf of the user so the user doesn't have to enter the username, passwords, or any type of SSH keys themselves. And to do that, we'll create a credential store. Let's create a new one. We'll call it built-in for built-in credential store. We'll select static. We'll say save. We'll then go to credentials and add the credentials. We'll give it a name. This will be a key pair. Username will be Ubuntu. And here's the key. Save. And now if we go back to our target, we'll simply inject the credentials that we just saved from our credential store. So now we are all set for our target. So now we can test out the connection from an end user's point of view. But before we do that, let's go back to our worker and close the security group inbound rule so that it does not allow any inbound access. All right, so we no longer have inbound access. And if we go back to our previous terminal, you also notice that we cannot connect or run any commands because the connection has been severed. So now let's log on as an end user using my desktop client. You can also use our CLI client if you prefer. And for simplicity, I'll just use the admin login. Once logged on, I can see the target that we created earlier, and here's the alias for that target. So to connect, I just use my SSH client like the one on my terminal, or you can use PuTTY or any other preferred SSH client. Once I SSH in using the alias name, you can see Boundary connects me right into my Ubuntu target without requiring credentials. Even despite having zero inbound access, using multi-hop sessions as a developer or any remote user, I'm able to still connect to my infrastructure resource in a secure manner. So in summary, with multi-hop sessions, we've allowed organizations to maintain strict and complex networks while also making it effortless for the end users to connect to their infrastructure resources. And that concludes our demo on multi-hop sessions. I hope you found it helpful. If you have any additional questions, please go ahead and comment in the section below. Thanks for watching, and see you again in our next video.